Hey guys, welcome back to the Dumont RA-102 console television restoration project, better known as the Clifton. Now, in addition to going through and replacing the few remaining paper caps on here, we do have at least 5 twist-loc electrolytic capacitors to deal with. Now, as I noted earlier, they barely twisted these on. So each one of these caps, now what am I talking about? I'm talking about these guys. They punched holes, they cut 4 slots, they put tabs through there, they twisted them over, they hooked up the cap. But they just barely twisted these over. All I have to do is that, and I can get it out. I'm used to seeing them more where they cranked them over 90 degrees or more, and if you untwist them, they snap off. And then you're left with, well, hunt down a new old stock capacitor and either use the whole thing or cut it open and get that mounting plate out with the twist locks on it. Anyways, just make more work for yourself. Alright, so I know I can get them out very easily and with a minimal amount of stress to them. Okay, then what? Well, I got a few options for replacing these. One, I could just leave them in there and mount new caps underneath. Heck, this is a single section cap. I got tons of room in here. Mount the terminal strip, mount the cap there, move this wire over, we're done. We do have 5 of them though. That's only one section. This guy has 3, that guy has 3, and another has 4. So we would need to put on basically 5 new terminal strips, mount a dozen or so caps underneath here, alter the wiring slightly. But from the top side it would look pristine, it would work. There's a little bit of a heat issue because this does have a metal plate underneath, so there's not going to be a whole lot of ventilation up here, so put all the caps underneath, and if it gets hot under here they're going to suffer a little bit. So that's one consideration. What I'm leaning towards though, because they're so easy to get out, is, well, let's restuff these. So to do that, there's a few ways. Well, I could try to cut them open in place, but there's a lot of structure up on top, so I don't want to do that. Plus, they're easy to get out, so I'm far more inclined to just remove them. So remove it, and you have a few options. Slice them open. Pipe cutter, hacksaw, Dremel tool, whatever. Get out the insides, drill some holes, feed the new cap leads through, wrap them around, wire them up, done. Put it back in, twist the things over, hook the wires back up. That's what I and many others do many times. But then there's a more labor-intensive way to do it, which will make it look like it's never been touched, which is to get the cap out and then uncrimp the aluminum around the bottom, get the retaining ring out, pull out the insides, put new caps in, put the base back in there, and crimp it back over. That's what I will very likely do. But not right now. Right now, what I want to see is, do these have some life left? This is a valuable, rare set that I went to a lot of effort and expense to get. I'm not crazy about running it indefinitely, especially not unattended with the original caps in there. However, while it's on the workbench and we're trying to bring this thing back to life, if they reform okay, and they seem to be okay, we could run it for a while on them. So let's test one. This is the easiest one to get at. I got to check what value and voltage rating it's got on it. Let's hook up a capacitance bridge and see how leaky it is and see if we can form it up. Alrighty, it's a 40 microfarad cap rated for 475 volts. Goes to one side of the primary and the vertical deflection transformer. Let's see how she tests. Not a good sign. It's not doing anything, which is what you typically get with an open capacitor. Just make sure we get everything connected up securely. Grab a modern capacitor, show you what I mean. So where's that modern 47 microfarad rated for 450 volts. Let's clip that in just to make sure the testers are working properly. That's what you should see. It should light up and then go out as the capacitor charges up. And then light up as it discharges. This cap in the set isn't doing jack. Make sure again, definitely have it hooked up. So it's completely open. Well, it wouldn't short anything out or cause any damage, but sure ain't gonna work either. Well, I guess we have to replace that one. That is one non-capacitor. It's just a completely open circuit. We tried to test this with the bridge. And when the eye goes open when you're fully counterclockwise, that means it is open. How does the capacitor goes open? The electrolyte completely dries out. So, well, that answers that question. No, we are not going to be able to power it. Well, I could power it up. If the capacitor's open and it doesn't short out, yeah, you can power the setup, but the capacitor's not there to do its job, so you're going to have horrible hum interference. Bad things are going to happen. That I wasn't expecting. Alright, well, that's also the simplest capacitor, so if we're going to try rebuilding one, we'd do that one first, because it's just a single section, we can get our feet wet with it. And plus, I just got to do one more twist lock, and the thing will plop right out. Just noticed something else while working on removing this guy. Looking at this guy, we got some crusties down in here, so this guy has leaked. So that, yeah, we're just going to redo all these. There's no point in messing around. Now, I also wanted to point out something about how these are mounted. Notice on one twist lock tab on each of these cabs, they have a heavy bus wire going to the chassis. And this guy going over to here, that is to ensure a really solid ground connection, and not just rely on these twist lugs. They are soldered with heavy bus wire to ensure a solid ground connection. So we will be careful to do that too when we mount the new caps inside. Just undid that bus wire, straightened out the tab, and should come out. Just gonna straighten this one out a little bit. These snub nose pliers really make it easy. There we go. Still pretty heavy. Often when they dry out or they show up in circuit, they don't weigh much, but this still does. 40 microfarad, 475. Can's bulged. You can see that, but this right side is bulged out. Yet another reason to restuff these. Looking for something that's just straight I can put against it so you can definitely see the bulge there. So, yeah, it's alright. So, what I was talking about to open these up, boy, these have a really heavy knurl on them, is to undo this aluminum seam down here. Biggest challenge with that typically is just to get it started. And once you do, you can work your way around, kind of like opening a can. So, this one isn't so bad because there's only a single section. When there's four, and you got these four lugs, it'd be tough to find a good angle to get in there, but it's only one lug. I can just go right in here and pocket knife. It'd be a good way to get it started. Don't do this. I've done it myself. I've seen others do it too. If you hold this and you use a tool, you poke yourself. So keep your hand out of harm's way. And you need to get in there. So the outside of the can, aluminum. This ring is steel. So you can be a little more aggressive pushing against that inner ring. But we don't want to mess up this material too much because we want to fold it back down. It will get work hardened from doing this. It'll likely form some stress cracks. It took about 15 minutes to work my way all around, and the ring is loosened up. While I went around, I noticed a lot of powdered debris underneath that knurled edge, which I'm guessing is from the dried out electrolyte. Curious to see what we find when we pull the insides out. I'm not sure why the ring is loosened up on one side, but it's really not on the other. It's really fighting me. Oh. Sometimes buying those new canned capacitors doesn't sound so bad after all. There we go. There'll be a little tab spot welded to it. Powder coming out. Alright, now if we're real lucky, I can just yank on this and pull the insides out. That's one downside. There's only one tab, and there's four, so you can sometimes grab them and twist, and the whole thing will pull out. In this case, I may have to get a heat gun out. Sometimes there's a blob of tar down inside holding the insides in. See, we really don't want to damage this because that's holding our lug in there. We want to reuse all this stuff. It's dried out like I think it has, and it's crystallized and all that. That could really be holding this in. Yeah, like I mentioned, I don't like doing this. Also, when I unknurled it, there's still a little bit of a indent around here, which is not doing me any favors. So I think what I'm going to have to do is get down in there and get a blade and walk it around. It's not going to be easy. Starting to think Plan B is looking more attractive, which is just leave all these in place and mount new caps underneath and call it a day. I'm going to take a quick look online too and see what the newly manufactured ones are there. I believe it's CE manufacturing, and let's just see what they have for 40 microfarad, 475. I also don't know if they go that high. They might top out at 450, but let's see what's out there. Alrighty, I went through the parts list, and here is what we need. There's actually 3 electrolytics on the power supply chassis. One of them is a dual 40 at 475, one is a 500 microfarad at 50 volts, and there is a single section 40 at 475, so that is it for the power supply. And the receiver has 5, as I mentioned earlier. 3 of them are 4 sections, 10 at 475. And one of them is a single 40 at 475. We just tried testing and opening up. And then finally there's one that's 3 sections. We have a 50 microfarad at 25 volt and then dual 20 at 450. Alright, looking through CE Manufacturing's offerings at amplifiedparts.com. So far, the trickiest one has actually been the 500 microfarad at 50 volts. The only thing I can find that's close to it is this. It's a dual 50 volt, 150 microfarad at 50 volts and 300 microfarad at 50 volts. So I put them in parallel, I get 450 at 50 volts. Now, if you look back at the specs, they do list a tolerance. Here's a power supply chassis. For all these electrolytics, they are where are we at? They're all plus 40%, minus 10%, which is pretty common for an electrolytic. So minus 10% on a 500 would be 450. So given that it's a new manufactured cap, and it's supposed to match the original specs of Mallory, which would be pretty similar to the Sprague, yes, there's a possibility that the other one, if it's 10% low at 450, will be closer to 400. But I'm willing to gamble that if I tie those two together, it's going to be in the ballpark of 500. I don't think it's super critical. Anyways, all right, let's move on to the others. And now they have a filter over here on the side, so I can select 10 microfarad. Let's try to find those 4-section guys. And they're 475, 500, and 525. We need at least 475. So we do the 525. So when you pick the 10 microfarad, they mean one of the sections is 10 microfarad, not all of them. So we got a quad, or a triple 30 and a 10. And this one is a 60, a 40, and a 10, and a 25. Okay, forget that. How about if we go with the 500? There we go. 500 volts, 4 sections of 10. We can use that. Not crazy that it's only rated for 55C and not 85C. It seems odd, but 55 degrees Celsius is pretty toasty. It's on top of the chassis. It's probably not really a concern. Again, that's where it irks me a little bit to not have detailed specs, but that's a possibility. And they did have something listed at 475, or a number of offerings. Let's check, but I don't think there's a 10 at 4. Yeah, there's no quad 10 at 475. This is close, though. We have 2 sections of 10 and 2 sections of 20 at 475, and that's an 85C. So given a tolerance on these, and these values generally aren't critical, well, not generally, they aren't critical, I could probably go with this guy as well. And then I'd get my 85C temperature rating. So I gotta think about that one. Okay, what's that leave us with that we still have to hunt for? The 40. Okay, so there's 2 of those. We have 2, one of the power supply, one of the main chassis. It's a single 40 at 475. That one's actually also a little bit challenging because they don't have any caps, I don't think, that are single section. So we have a choice of we can get a 40 that's dual and just not use half of it, or we can get a dual 20 and tie them together. So if we go 40 at 475, we get this, which is a 40, a 20, a 20, and a 10. So we could use the 40 and forget about the other 3 sections. That's not so great. How about 500 variety, 3 section and 2 4 sections? Again, not so ideal. 525, 3 section, 4 section, 4 section, 4 section. Not really liking that either. Okay. Now we could also go a little bit higher in capacitance. So they have 40, but they also have 47. So let's check that out. Oh, we got some of the firecracker types. And that's only 350, so yeah, I can tell you right away, none of those are going to work. We could bump up to 50, possibly. And they don't have any, they're 475, but they got a 500. Could use half of that guy. Would work okay. Well, let's check out using a 20, and we can tie the 2 halves together. 20, 475. There's a 20 and a 30, 475 tied together. We have 50 at 475. That should work fine. Again, we got the plus 40%, minus 10% tolerance, so we're within that range. And let's check the 500. The reason I'm doing this is to give you all an idea. If you decide to go with these, you're going to be doing this too. Because the odds are you're finding exactly the value and the voltage ratings that you need are slim. How do they come up with these? I imagine they went with popular guitar amps and radios or whatever. Supply and demand. Alright, here is my final selection and final tally. 8 capacitors for $303.60 plus whatever the taxes and shipping come out to. Is it worth it? I'll leave it up to you. But I can tell you this. Time is money. My local mechanic, I just had some work done on my car. It's $95 an hour for labor. It will take me hours to unmount, pry open, restuff, reseal, remount, rewire the caps. I'm sure I can install all of these guys in less than an hour. It's worth it to me for this project, which is one of my favorite sets in my collection.